Hello my friends, welcome to another episode of Inside Out Electronics, and today we're gonna take a look inside of this Mean Well SE-450-24V power supply. I own it for about 7 years or 6 years. I got it right away to replace my power supply, which came stock with the 3D printer, because whatever they included with 3D printers was shit power supply, probably a fire hazard, and I decided to get this one. And since then, this thing was working perfectly. It is still working. The only thing is, I noticed it accumulated a lot of dust inside. And today I would like to open it up, clean it up, and also we're gonna take a look what's inside. On this side, it's non-standard part, so I've created a little enclosure over here which has USB power, which has volt and ampere meter. Also it has this power switch and things like that, just because you want to nicely encase all those bunch of wires in something which look nicer, and also offer some protection against fingers. Against fingers. You're not gonna shock yourself fiddling with this power supply, because this is not a consumer level power supply. This is more like a power supply unit which is supposed to be inside the product. Alright, so let's take a look. First of all, we have to remove this part in order to get inside. I have only 2 M4 screws. So I removed those 2 screws and let's slide this thing away. So over here, those 2 wires, those 2 actually is under load. They are in between here. There is a shunt resistor which I'm measuring the voltage drop in order to figure out the current. So here we are. This is the back side of the Oh, interesting. Those are not connected. But why they are not connected? Did I forgot? Anyways, it's kind of hilarious. I completely forgot to wire the sense wires. Crazy. Oh my god, whatever. So this power supply is great because it, in addition to just supplying for voltage, it has also sense wires. So if you are at the end of your load, for example, by the way, this is Keycon connector which my 3D printer uses. Weird, I know, but you can connect those to your sense lines, and power supply will compensate if there is a voltage drop. So maybe I'll take a look at that later. Oh, I know why. Because sense wire requires special connector, and I decided to not fiddle with it because I don't have one. Yeah, now I remember. Alright, so let's open the power supply. I cannot remove this thing because otherwise I would have to disassemble all this, so I'll keep it on. Okay, we are in. And here we are. Here's the power supply. This is... It's hard to tell what kind of fan is this. I'm gonna disconnect it for now, because that has to be cleaned up. 24V goodness and some unpopulated business. Interesting. What is that? This thing doesn't have active PFC, power factor corrector. Potentially this is unpopulated PFC business. I'm not exactly sure. It's not that dirty, I must say. It's not that dirty. Oh, find the spider. Oh my god, there is a spider here. Look at this. Cute spider. Huh. Cute spider, or like how you say it. Cute spider is dead spider. Okay, let me find my pokey bits here. Okie-dokie. Well, you know what, just for aesthetic reasons, before I go and dive into some sort of analysis and things like that, I'm probably gonna clean it up. Probably cleaner, it will look so much nicer. Okay, now everything is clean and dandy, and let's talk about a componentry over here. So let's start from primary. Let's move this a little bit further. So those three wires are ground, a live, and neutral. So obviously the ground is, oh my god, it's wobbly here. Yeah, I guess I wiggled it out, so I have to tighten this one. So ground is close to negative over here, and they are actually, I think they are on the same, actually connected. So ground and negative is connected. I'm pretty sure. I have to double check that. There is another negative, there is another negative, there is a plus, plus, plus. So just in case you're not going to be able to short anything, plus those spades over here are pretty tall, so you won't be able with your screwdriver to fiddle. Plus also I connected it as far as possible, connected my wires as far as possible from this end. Alright, so if you talk about logical layout over here, so a primary side goes like this. I think this is the primary side. Here's the primary components, the primary capacitors, a diode, and here's the driving circuit, transformer, feedback, and then there is a secondary side. There's diodes and filtering capacitors and so on. So let's talk about details over here. So over here on the primary side we have a whole bunch of coupling capacitors. In between, it's really hard to tell, is it okay, in between what they are, because I don't want to pull the board out, but I assume they are in between in this case potentially, obviously case is grounded by the way as well, between a ground and a neutral, and yeah, it's really, actually honestly it's really hard to tell. Maybe those markings F, P and SF mean something, but I honestly do not understand what that means. If someone would comment what S, F, P and S markings on those capacitor leads really means. So this capacitor has also the ferrite bead over here, probably to cut on some transient currents, or I don't know. So very important, there is a fuse, ceramic fuse, 15 amp 250 volt, 15 amp fuse, very nice. So over here we have mauve, and probably mauve, and this CLC L filtering is part of the input filtering, and this, I assume this resistor over here is to discharge those capacitors to the safe levels, or discharge them completely. Pay attention to, if you pay attention to those chokes, there is a very interesting, they have a divider over here. It's 4 layers of PCB glued together. This is to make sure between neutral and live there is no any possible like short. So in addition to being like completely wounded on different sides of the choke, they also separated by these physical 4-layer PCB kind of glued together. So here we are. This is how a physical separation in between those wounds or a windings of the choke look like. So it looks like a little sandwich with chocolate glued together here. So here's another one, and I think there is even notches in the, or maybe not. It's my imagination. It looks like there is a notch in that toroid, but looks like not. It's just some sort of epoxy. This is actually quite nice. Then we have this Ptc Thermistor. It's again for protection from over voltage and from the surge. Then there is something interesting. There is a relay over here, and relay is the relay. A bit of close up on it. I'm not sure what this relay does. Probably it clearly for switching, but switching of what, I don't know. Yeah, over here I have to investigate, but because I wanna pull the whole board, so I won't be able to tell. Maybe I won't be able to tell at all. So here we have a voltage switch, switching between 110 and 220 or 240, primary bridge rectifier, and 2 big ass capacitors. Those are Rubicons, 85-degree actually rated. Maybe this is okay in this particular scenario. They are for 200 volts, 680 microfarad, which is awesome. There is a whole bunch of MOVs over here, more capacitors over here, two small transistors, both of them branded Mean Well. So no, sorry, this one is not branded Mean Well. This is just a generic. What we have over here, we have another, it's a diode, and hard to tell what is this. Oh, spider, found another. No, it's a fly of some sort. Go away. No, it was not diode. This is actually a switching transistor. So yeah, and this dude, it's really hard to tell. Oh, by the way, this is cool because leads on those transistors have ferrite beads on them. On all of them, actually. That's really nice. Again, I don't want to disconnect it at this point. So there is also a thermistor connected over here to monitor the temperature of these guys, and probably gonna shut off during over voltage. Over when this go over certain temperature threshold. Then we have a driver chip. I noticed that the pretty much majority of capacitors over here, they are Rubicons, except those two. Those two are Nichicons, which is awesome. I don't see any big rate kind of capacitors over here. All primary over here and secondary, all of them are Rubicons, which is really good sign that this capacitor is going to live longer, especially on filtering over here side, because the current is much larger over here than on this side. Obviously, because it's higher voltage. Okay, so this is transformer, and it's not really shielded. So sometime in other power supplies you can see that this completely encased, but in this case it's a Mean Well branded transformer, but it's not shielded. And feedback optos are right there, and there are two of them, not one. Here's the interesting capacitor over here, and it with a little ferrite bead as well. With little ferrite bead as well. Then obviously we are approaching towards secondary, and here I found a very interesting thing. This is apparently a voltage regulator. It's a 12-volt voltage regulator, and here is, I assume this is minimal componentry for this voltage regulator. Two how do you call them, capacitors, Rubicon brands as well. And they are highly likely they are connected to this CN101, which is where this thing connected. Alright, so this is fan control, and it's kind of, I can wrap my mind the following thing. This is 12-volt fan, 24-volt power supply. The only explanation would be that because this is exactly the same layout, plus minus few components is used for 12, 15, 24, 48, 64, you name it voltage. That's why they stick to 12 volt. But in this case, it's like, it's just pretty much asking, like, remove all this crap and put 24 volt a fan over here without like extra componentry. But you know, they decided to use a separate voltage regulator, all surrounding componentry around the voltage regulator to actually power 12-volt fan. But I mean, what about 12-volt or whatever, 5-volt power supply, 3.3-volt power supply? So this fan has to be 3.3 volt, I guess. They're not gonna step it up, right? It's kind of stupid. So, okay, so here is big ass a filtering choke. Obviously it has to be big ass because it looks like there are several wires soldered together. So this looks like a three or two. It's really hard to tell. It looks like three. So this guy is serious. Has to run up to 400. So this is 450 watt, and it's like what, 18 amps can pass through this thing. And there is a filtering capacitors, and that's it. There is another little filtering capacitor over here. So there is also a little part which is about voltage regulation. I thought, there is a result trimmer over here. We can actually wiggle and control and trim the voltage. For example, if you want, for whatever reason, either you have higher load or very high load, and which not changes, and it's gonna sag to 23.5 volt, you can just trim it to 24. Alright, or something to this extent. Or you can use sense wires, which I intended to use, but they are not connected, just because this little thing over here is very proprietary connector. Either I have to like solder it directly to the PCB, which would require pulling it out, or figure out how else I can connect it to this connector, because yeah, it's totally proprietary thing. You just use regular standard GST, it'll be so much easier. Or DuPont or whatever. Yeah, this is pretty much it. I think this is really good quality power supply and gonna meet all standards. Probably EMI as well, despite I think this capacitor transformer can be kind of better shielded, but because everything is grounded and everything is enclosed, maybe this just works a treat. There is also something unpopulated over here. Potentially this is part of the active PFC regulation, because this guy, I don't think it has. I don't think it doesn't have PFC. I have to double check. Maybe I'm wrong about this guy, but I don't think it has PFC or active PFC. Sorry, and there are some chippies missing. So maybe this is for it. Maybe there is a version, exactly the same version, but with PFC. Have to double check that. Not sure what's going on the other side, because I'm not gonna take a look. Too many things has to be disconnected in order to do that. And then I want to reseat all thermal pads and things like that. Just a little bit too much work. Yeah, looks like wires. Some of the wires are not cool. Then I would like to do the following. I'm not sure if you are owner of this power supply, you probably notice at the moment you power it on, it's loud, right? This thing has this big ass fan, which is crazy loud, and it works all the time. It doesn't matter if you just power it on, nothing connected, this thing is going. So I'm gonna illustrate you how loud it is. Okay guys, get ready to be deaf. Well, actually, it's not as bad, but for some reason it's so much worse when it is in the case, but it's still pretty loud. You hear it? It's getting worse when it's like inside the power supply. It's really powerful fan. And by the way, it always runs and consumes 1.4 watt, like constantly. Okay, so my idea is to use exactly the same size, way smaller fan. Reason I'm taking this decision or going this way, because I know that I'm using pretty much 240 watts maximum, maybe 280 tops. This essentially means that in case this power supply not going to run at its maximum. Maybe it's not necessary to run this big ass fan constantly. So I'm using this way smaller fan, which is supposed to be way quieter. So this is gonna be 12 volt, 180 milliamp fan. So let's give it a try and let's listen how this sound. It's a bit shorter lead. Actually, I must say this is loud as well, but not as loud. And it's actually quite windy. Huh. Unfortunately, I don't know specs on this particular fan by Delta Electronics, which is actually pretty decent fan, I must say. I think I pulled it from some kind of CPU cooler from old ages, and it still decently works. So yeah, I'm gonna install this. First of all, it has smaller profile and it's a bit quieter. Let me put it all together and we will listen how it sounds. I assembled it back together and let's try to listen how it sounds with not this big ass Sunon fan, but with a quieter Delta fan. Well, it is quieter, but not much more. Wow. Whatever. It is definitely quieter than with this big guy, but it's not much more quieter. Okay, so maybe if I would install some rubber gaskets, that may be actually quite an improvement, because it looks like the fan itself is relatively quiet. Even this guy is relatively quiet, but when it's encased in this metallic fan, it's make it much louder. It sounds sort of like resonates. So I think it's gonna wrap up. Also, I was lucky enough to find and MacGyver something over here, so we're gonna connect my sense wires. So in this case I'm gonna run a 24 volt and also run 2 sense wires. In this case it probably gonna make a bit of improvement of a 24 volt quality output. Maybe my printer heat bed gonna heat up a little bit faster. Alright guys, I put it all back together. It's operational, also connected sense wires, and they are operational as well. So also, if you are interested to make this enclosure for this particular power supply, because it's really designed specifically for it, or for some compatible power supplies, maybe there are some with very similar dimensions, you can head out to Thingiverse, which is gonna be down below. You can, make one yourself, especially if you want to have a USB power 5 volt, or you want to have this voltage and current measurements right here on this very nice power supply. So general verdict, this is very nice power supply, gonna serve you a long time. It's not super cheap, but it's very well done. So guys, I'm gonna wrap up on this one. Thank you for watching and see you next time. Please don't forget to subscribe.